Good morning. This is your Stats Sensei, Mr. Spensei, and this is Death Packet video 3 on displaying and describing data, which is a unit 2, and this is going to be problems 21 through 30. All right. Questions 21 through 24 refer to the following study. 500 people used a home test for HIV, and then all underwent more conclusive hospital testing. The accuracy of the home test was evidenced in the following table. All right, so here we go. First off, they give you a table like this and it doesn't say total. You need to go ahead and take the time to total it. So 35 and 5 is 40. 25 and 435 is 465. Excuse me, 460. And that sums up to the 500. 5 and 435 is 440. That sums up to 60. And we all sum up to 500. Okay, what is the predictive value? I don't have a clue what that even means. That is, what is the probability that a person has HIV and test positive? Well, positive and has it is 35 out of 500. And if we take that and we divide it out, 35 divided by 500, 0.07, we get A. B, what is the false positive rate? That is, what's the probability of testing positive given that the person does not have HIV? So remember, it's always intersection over given. So we're given that the person does not have HIV. So that's 460 people. And it's the given tested positive. So this is healthy, positive, it intersects at 25. So 25 over 460. And we end up with 0.054, which is A. All right. For number 23, what is the sensitivity of tests? That is, what's the probability of testing positive given that the person has HIV? Once again, it has a given. And remember, it's always intersection over given. So given they have HIV, well, 40 of them have HIV. What's the probability of testing positive? Well, that's 35 out of the 40. Is 0.875, letter E. And lastly, what is the specificity of the test? That is, what's the probability of testing negative given that the person does not have HIV? So they're healthy. So that's what, and remember, like I said, it's intersection over given. So healthy is 460 and testing negative is 435. So 435 divided by 460 is 94.5%, or about 96%. Our answer choice is E. All right, moving on to the next one. What is consider the following ages of senators? All right, so we have these ages. What's the probability a senator is under 7 given that he or she is at least 50? All right. Well, 40, less than 40 is not 50. 40 to 49 is not 50. 50 is. So this is what I was given. All right. So my denominator is, and remember, it's always intersection over given. So in this case, we're given the denominator is 36 plus 22 plus 5 plus 2. What's the probability is under 70? Under 70, I'm going to use a different color. Actually, it goes all the way down here, but the part that we're interested in is where it overlaps. And the overlap is right here. So our numerator is going to be 36. plus 22. So 36 plus 22 is going to be 58. And our denominator is going to be 36 plus 22 plus 5 plus 2 is 65. So when we take 58 and divide it by 65, we end up getting about 89%. And our answer is D, 0.892. A study of this on a school budget approval among people with different party affiliations resulted in the following segmented bar chart. Which of the following is greater? The number of Democrats who are for the proposed budget. Well, I don't know how many people were chosen, and since this was talking about the number, I'm not in a good shape because over here I'm dealing with percentages. I don't know if there's 1,000 Democrats or 1,000,000 Democrats. I don't know any of the. I don't know the number of Democrats, Republicans, or Independents. I can't make that choice. The number of Republicans. Once again, I don't know that value, so I can't do it because I don't know how many Republicans there are. The number of independents, same reason, can't do it. I don't know how many independents there are, so I can't multiply by the percentage. The above are all equal. We can't make that comment because we don't know the actual number. So the answer is impossible to determine without additional information. Bing, 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 we have a winner. All right, 27. The following table shows the number of miles a hiker walked on a trail each day for 6 days. What was the mean number of miles that a hiker walked for the 6 days? So here's what we need to do. We need to go back into StatEdit. And 1, 2, 3, 4, 5, 6. Those are my days. 1. Oh, no, I don't. I don't even have to do that. Excuse me. I just need to ask for the mean. I just need to add those up and take the average. So basically, 8 plus 5 plus 7 plus 2 plus 9 plus 8. So 8 plus 5 plus 7 plus 2 plus 9 plus 8. And I'm going to divide all of that by the 6 days. But when I do that, I get 6.5. I do want to point this out on the calculator. I could go into StatEdit and put in 8, enter, 5, enter, 7, enter, 2, enter, 9, enter. All I did was put all the data into the calculator. And I could go stat, calc, 1 var stats. And there's my 6.5 because that's my X bar. All right. So I could use the calculator to do that, but this time I could have just added them up and divided by 6. Because when they're asking for the mean, they're asking for the average. All right. Number 28. The following list shows the number of goals scored by a soccer team in each of 9 games. How does the median number of goals compare with the mean number of goals? Well, let's look at this. I could go back to StatEdit, probably the safest and easiest thing to do. I'm going to clear that out. And I have 0 goals, 0 goals, 1 goal, 1 goal, 1 goal, 3 goals, 3 goals, 4 goals, 5 goals. All right, so I've entered the data. And I can go stat, calc, 1 var stats. And I find my X bar, which is my mean, is 2. I can scroll down 1 and my median, which is the middlemost value, equals 1. All right. The median is equal to the mean. No, it's not. The median is less than the mean by 1. Yes, it is. All right. So we should be good with that one. Next problem. When a data set has suspect outliers, which of the following are preferred measures of central tendency and variability? All right, so measures of spread. Mean and standard deviation are greatly impacted by skewed data and by outliers. We don't like that. The mean and the variance, both impacted. Mean and range, extremely impacted. The median and range, the range is impacted. The median is not. We like that part, but we don't like this part, so don't like D. The median and interquartile range, the middle 50% of the data is not impacted, and the middlemost number is not impacted by outliers. So we like 29, we like E. Of the following data set, of the following dot plots, which one has the smallest standard deviation? To have the smallest standard deviation, you want the most data in the center. You want the, all right? Well, this one is spread out nice and neatly, but it doesn't have a whole lot in the center. This one has more in the center, so this is better. This one has more in the center. Now we're getting less in the center and further less in the center. So we like this one the best, letter C, because it has the least amount of data in the center. All right. All right. Well, that concludes this video. I hope to see you on the next one. Thank you for watching.